I am Rajiv. I am going to talk about a solution for multi-hop dissemination. So let me talk about the problem first. The problem is pretty simple. So there will be a master node. In my program, 13 in the middle is the master node and 24 other slave nodes. So whenever a master node sends a message, it has to be sent to other slave nodes. The main problem is whenever the master node broadcast a message, so there might be a possibility that all the slave nodes is not getting the message because of the distance of the network. So whenever a master node send the message, the nearby nodes will definitely get the message, but there is no surety about that the other nodes of the furthest corner, maybe 1 or 21, will get the message. So here we have to implement some multi-hop techniques. So whenever a master node send a message to the nearby slaves will also broadcast the same message to the so that the other slave nodes get the notification. So here I have solved this problem. I will talk about the implementation later. So let me show you how this looks like. So those little uh, three bars is just simply the structure for LED. So if the red LED is turned on, it will just uh, show in brighter way. So let me run this code. Yeah. So now, so it's starting. So I have set a 5-second interval in each iteration. So in each 5 second, the master node will send the message to other slave nodes. So here you can see the message is transferred to all the messages, all the other slave nodes. Yeah, and if I pause here, you can see that. So this is the master node, and here red and blue is now turned on, and all the other slave nodes it also have the same LED state. So let me just go forward. Let's see, is there anything weird behavior is happening here? No, every other slave nodes also have the same state, in every other slave nodes. Yeah, yeah. Okay, so basically when a master node send a message to other node, this node also broadcasts the same message to other slave nodes. That's how this message is spread over all the network. So this is a multi-hop dissemination technique. So let me talk about the implementation now. So here I have the code for this solution. So here I just set number of nodes to 25, and the master node is 25 by 2 plus 1 is basically the 13. This is my, yeah, this is my thread. So in this thread I just check if the node ID is master node, then I am the only one is able to broadcast the message to all over the network. So basically what I am doing, I am just getting the random color, and I just called let's toggle, and then after toggling I want to know what's my current situation of the LED. So I just call let's get, then I will get a LED mask. So also I am using a sequence number because in each iteration I have to know which sequence which message of the sequence I got, and I am sending the current LED state. Okay, so yeah, so here I just broadcast using the nullnet. I just got the code from nullnet example. This is pretty simple. Okay, so that's what is done in master node. And now let me talk about when any node receives a message. So here I had just written a a case that if the master node receive any message from any slave node, the master node will just skip it, because in this problem master node is not gonna do anything if he gets from any message from the other slave nodes. So this code is basically for the other slave nodes. So every node will be started with the same sequence number 0, and whenever any slave nodes gets the current sequence from the message, and then it just simply check if the current sequence is greater than my own sequence, then I will perform the operation, and also I will broadcast to the other slave nodes. It's a pretty simple solution. This way, yeah, I just easily can handle the broadcasting message buffer, yeah. So that's how the implementation look like. Now I'm going to talk about the evolution of this scenario. So for this, I just iterated with 9 nodes, with 25 nodes, and also in 49 nodes. And from 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 number of iteration, I mean, I just iterated 25 iterate 27 yeah, 27 iteration. And in each scenario I just checked if all the nodes are getting the same getting the message or not, and how many I mean, what is the maximum difference of the latency to reach the message to the furthest node from the master node. So I think this log is not meaningful to you, so I just written a Python script uh, that will analyze these log from yeah, from here. So here we have generated a log. So I have written a Python script that just analyze the log to show the meaningful data to the user. So basically what is doing, if I just open open a simple log, then it shows which node ID at what time, and which sequence number of messages, and what is the already task is getting. So this is pretty simple. So from this log I can just determine uh, how many nodes already got the data, and how many nodes didn't get the data, and what is the latency. So let me run this log analysis. So yeah, here I get the first graph. From this graph I can easily see that if I have 49 nodes, then the average latency is 174 millisecond. Yeah, also some if I have 25 nodes, the average latency is 138 to reach the message to the furthest node. And if I have 9 nodes, the average latency is 72 millisecond. So these three graphs is for different number of nodes in the network. And let me show you another graph for the reliability test. So this is the reliability test. Yeah, so here if I have 9 nodes, I can see that I can have 98% reliability. That means there are some scenarios that the master node send the message, and all the other slave nodes didn't get the message. Maybe one or two slave masters missed the message. If I have 25 nodes, I have 98.96%, and if I have 49 nodes, I have 99.39%. So even though we are increasing the number of nodes, the reliability is not dropping out that much. So we can increase more nodes without any problem in this multi-hop dissemination scenario. So this is a pretty nice technique to send a message from to all the network. Yeah, so that's what I just wanted to show. Thank you. Thank you very much.